Okay, so question 1 on this second series of exercises. This is from your book, 10th edition, the problem 2.19. So we have a circuit, we have an independent current source, and we have 3 resistors. So the question says find the currents I1 and I2 in this circuit. Okay, very good. Okay, so this is one node. This is a node. So node A, and I can write KCL on this node. So write KCL on that node. Remember, I told you the convention that we use. For the current that are going out of a node, leaving a node, I put plus. So I1 and I2 are exiting this node, I1 plus I2. And then there's a 1.5 amp that are entering this node. So I put minus 1.5 equal to 0. Okay, so in other words, I1 plus I2 equal to 1.5. So that's a KCL. Also, I can see this loop here, that I can write a KVL on that. KVL. Okay. You might think, okay, why don't we just write the KVL on this this loop, the first loop, and the left? But that won't be very helpful because we don't know VO here. And also it doesn't involve I2 because we want to find I1 and I2. So we are looking for equations that have I1 and I2. So therefore I will write the KCL on this loop that includes I1 and I2. Okay, so let's start from here. So 150 times I2, because I'm going this way and I2 is in the same direction. I put 150 times I2. So basically, or you can see it another way, that because I2 is going this way, so plus and minus V2, the reference direction are that way. Okay, so this could be V2, this could be V3, and this is I going through that, which is exactly I2. So still I2 is going through this I2, and then this one has I1. Okay, so this is V2 basically. You can write V2, but then you have to use, okay, V2 is equal to 150 times I2. So that's why I directly just say RI, 150 times I2, plus here 250 times I2. Remember, these two are in series of each other. The elements that are in series, whatever I is going here, it's going to also go there. The same current. So 250 times I2. We are moving here. Okay, and then now this is interesting. We have 100 ohm current, 100 ohm resistor, but then the current is not going this way, going that way. That's why I put minus 100 times I1 equal to 0. Okay, so this is important part. So basically, you can think of this that I1 is going down, so plus minus V1 is like this. Okay. So therefore, when I was going through the KVL, I hit a negative. See, I hit a negative sign. Okay. You can then say that or say, okay, the I1 is in this different direction. I was going up, but the current is going down. So that's why you put a negative. So the more that you do exercises, the more you will know just automatically what is plus, what is minus. So again, I go through the loop, 150 times I2 plus 250 times I2, and then minus 100 times I1 equal to 0. Very good. So we had 2 unknown and 2 equations. So the first equation was I1 plus I2 equal to 1.5. The second equation is 150 and 250 is 400 I2, 400 I2, and then minus 100 I1 plus equal to 0. Okay, so it's simple actually. We can, if that's the case, someone can simplify this. this 400 I2 is equal to 100 I1 equals 4. So basically I1 is 4 I2. Okay, and then the summation of them also is 1.5. So basically I replace the star in this equation. So I1 is 4 I2 plus I2 equal to 1.5. So 5 I2 equal to 1.5. So I2 is 0.3. So I2 is 0.3 amp. And then I1 was 4 times I2. So I1 is 4 I2, which is 4 times 0.3, which is 1.2 amp. Very good, okay? And then we can double check. If I1 is 1.2 and then I2 is 0.3, the summation of that is 1.5. That's good. And we can also check the KVL, but I guess that, yeah, we did correctly. So this is the part A. And then part B says find the voltage, VO. Okay, VO is exactly equal to V1, right? So VO is 100 times I1. So right here, VO is basically the same as V1 across this resistor 100 ohm. 100 times I1, 100 times 1.2 amp, which is 120 volts. Okay, and then part 3, verify that the total power developed equals the total power dissipated. Okay, so for power, basically we have all the currents and we have for resistor, we can use just V equal to Ri. So let's see. P1 is the power of the 100 ohm resistor. I use RIS. Yeah, I can use RI square or VI. Doesn't matter. RI squared. R is 100. The I1 is 1.2 squared. So 100 times. Not mistaken. 144 watts. It's a plus, so it's consuming the power. The same with P of 150, Ri squared again 150 times I squared. The current is 0.2 squared. Okay, for this one I probably need to use calculator, and then for the 250, P of 250 again is 250 times its current squared 0.3 squared. And so we can calculate this, but also let's do the power on the current source. The power of the, I will put this as the current source. I use VI, okay? But just remember, I have to use, if I look at V plus minus here, so V was 120 volts. But then the current has to go this way, conventionally, if it's positive. But because it's going that way, I have to put minus or negative 1.5. Okay, so let me use my calculator to calculate all of this. 120 times negative 1.5 is negative 180. Negative 180 watts. And then 0.3 squared by 150, 13.5 watts. And then 3 times 0.3 times 250, 22.5 watts. Okay, so the 144 and 13.5 and 22.5 is exactly plus 180 consuming. So the total of 180 is being consumed, and on the other hand, 180 is basically delivered. So the summation of all these four numbers are equal to 0. So therefore, we did the math correctly, because now all the power adds up to 0.